In this video, I'm going to go over 3 examples of calculating with percent by mass for solutions. So our first example here says, according to a lab procedure, you stir 30.5 grams of magnesium nitrate into 430 milliliters of water. What is the percent by mass magnesium nitrate in the solution? So in this problem, the first thing that we need to realize is that it's asking us for percent by mass. Okay, so we've got percent by mass. Then we're going to figure out what is our solute and what is our solvent. So our solute is going to be what we have less of. Well, when we look at these two things, one's in grams and one's in milliliters. So that means that we need to switch one of them so that they're both in the same thing. And that thing that they need to both be in is grams, because this is percent by mass. So when we're looking at water, water has a density of 1 gram per milliliter, which means that 1 milliliter of water is equal to 1 gram of water. So that means that if I have 430 milliliters of H2O, I have 430 grams of H2O. Okay, so now that we know that, what I have less of, my solute, is the magnesium nitrate. Okay, so there we have it. Our solute is 30.5 grams of magnesium nitrate. Solvent is going to be the other 430 grams of H2O. My solution is the total grams. 430 plus 30.5 gives me 460.5 grams of solution. The reason I need the solution is because when I do percent by mass, I have the grams, or the mass, of my solute divided by the mass in grams of my solution, the total, times 100. So given that information, we can now solve. My solute, so percent M over M is equal to solute, so 30.5 grams of magnesium nitrate, divided by the total, 460.5 grams of solution, times 100. So now we work it out. 30.5 divided by 460.5. Then we're going to multiply that times 100. And that gives me 6.6%. Or if we wanted to go to the proper number of significant figures, which is 3 significant figures, it would be 6.62% magnesium nitrate. So you could write that either way depending upon the number of significant figures. So if your teacher is requiring significant figures, then you would go all the way to 3 significant figures. If not, you could probably stop at either the whole number or to the 10th place, depending upon what your teacher really wants out of it. So now we're going to look at another example. This example says how many grams of potassium bromide are in 275 grams of a 15% aqueous solution of KBr. So, it tells us that we have 275 grams of solution, and it tells us our percent by mass. If you remember, our calculation is percent by mass is equal to grams of solute over grams of solution times 100. So, this 275 grams is of solution. So that's your solution. The 15% is your percent. So now that we know those things, we can say, well, I'm missing one thing, and that one thing I'm missing is my solute. And the solute is potassium bromide. So we're going to plug in the information and see what's left. We've got the percent. 15% is equal to grams of solute. We don't have that over grams of solution. We do have that, 275 grams times 100. So what I'm going to do is I'm going to plug in a variable. My classic variable that I like to use is just an x. So 15% is equal to x over 275 grams of times 100. Now, the x is in grams of KBr, so that's what I'm going to write, x grams of KBr, so that I know what I'm looking for. Now I need to get the x by itself. So, step 1, let's go ahead, divide both sides by 100. So now we have 0.15 is equal to x grams of KBr over 275 grams. Now we're going to multiply both sides by 275 grams. So 275 times 0.15 gives me 41.25. So 41.25 grams is equal to x grams of KBr. So that means that we have 41.25 grams of KBr in solution. Now, what we were provided with was 275 and 15. If we're looking at significant figures, we always are answering to the lower number of significant figures if we're doing multiplication or division. So the lower number of significant figures, we have 3 in the 275 grams, and we have 2 in the 15%. So my answer needs to be to 2 significant figures. So to properly write this, it would either be 41 grams of KBr, or we would say 4.1 times 10 to the first grams of KBr. If your teacher wants you to put it to a certain number of decimal places, you would just round appropriately. So now let's look at our last example of our percent by mass. A can of chicken broth contains 450 milligrams of sodium chloride in 240.0 grams of broth. What is the percent by mass of sodium chloride in the broth? Okay, so it's asking us to find the percent by mass. So this is my unknown. It wants to know the percent by mass of the sodium chloride in the broth, which means the broth is therefore my total solution. So we have this guy there, that's my solution. And then the other thing, the 450 milligrams, is my solute. Now, here's the problem. I can't divide milligrams by grams to get a percent by mass. So I need both of these to have the same unit of measure. I could have them both in milligrams or I could have them both in grams. Either one works, but I have to convert one of them. The choice that I'm going to make is I'm just going to convert my milligrams to grams. So I'm going to start with my 450 milligrams. Now, if you remember, our conversion factor between milligrams and grams is that 1 gram is equal to 1,000 milligrams. So 1,000 milligrams are in 1 gram. If I take 450 and I divide by 1,000, that gives me 0.450 grams. Now this is of sodium chloride, because that's what it's telling us up there, sodium chloride. So that's how many grams. That's my solute. It's not telling me solvent, it's telling me solution, the total solution. So I take my 0.450 grams of NaCl, and then I'm going to divide that by the total, 240.0 grams of solution. I'm going to multiply that by 100, and that's going to tell me my percent by mass. So 0.450 divided by 240 gives me that 0.001875. I'm going to multiply that by 100 now, and that tells me that my percent by mass of sodium chloride is 0.188 or 0.2, or depending upon what we're looking at for the number of significant figures. In this case, it's 3 significant figures that I'm going to answer to. So that would be the 0.188% sodium chloride. But if your teacher's asking you to answer to a specific number of decimal places, you'll just answer as requested.